Hi all. Welcome to lesson 15, the geometry and algebra corner points. Okay, so we're going to start off by considering what we talked about last time before spring break. That's in this section here. The main punchline here is this last bullet point here. Corner points, when we say that, we really are talking about extreme points, and we know those are the same as basic feasible solution. Note that basic feasible solution has a number of different definitions involved in it. It has this notion of linear independence, and then it has the notion of basic solution, and then we have to still check feasibility. So let's illustrate that with the following example. So we have a polyhedron here with three constraints. Constraint 1 is listed there, and the constraints 2 and 3 are non-negativity. So the first idea that we're going to illustrate here is part A. We want to see if constraints 1 and 3 are linearly independent. So how do we do that? Well, we want to form the constraint matrix associated with 1 and 3, and we check its determinant. So the constraint matrix, remember, is coming from the coefficients. Here, remember the coefficients here are 1, 3, from the 1 times x1 plus 3 times x2. Here, remember, could be written as 0 times x1 plus 1 times x2 is greater or equal to 0, so this is 0 and 1. And we calculate its determinant. The determinant here is of a 2 by 2 matrix, it's just 1 times 1 minus 0 times 3, which is equal to 1. And we check that it's not equal to 0, and that means that 1 and 3 are indeed linearly independent. Okay, I abbreviated linear. Okay, so that's A. To do B, we want to compute the basic solution that's active at constraints 1 and 3. And then check these questions. Is it a basic feasible solution, and why? So what does it mean for there to be a basic solution active at constraints 1 and 3? Well, that means that we need to treat these constraints as equality constraints. So remember, active means satisfied with equality. Okay, so we look at the system, x1 plus 3x2, and I know the constraint is less than or equal to 4, but we're gonna make that satisfied at equality, so it's equal to 4, and then x2 equals 0. Right? It was greater or equal to 0. If it's active, it means it equals 0. Because of this, we know that this has a unique solution. Okay, that's what our theorems from linear algebra tell us. It has a unique solution. And indeed, if you think about this, x2 equals 0, that means the unique solution has x1 equaling 4, just by back solving. So putting in x2 equals 0, if we back substitute that up to the first equation, we see that means x1 equals 4. So the basic solution is let's be careful here, x equaling x1, x2 equals 4, 0, okay? And because well, 4 is certainly greater than 0, constraint 2 is satisfied too. So 1 and 3 are active, 2 is satisfied, and x is a basic feasible solution because everything is satisfied. Okay, so I was a bit redundant there. You don't need to write all of that. If you knew that you calculated the active constraints and then you just have to check the other constraint here, this was the important bit, we know that it's a basic feasible solution. Okay. Part C. In words, how would we find all the basic feasible solutions of S? We would do the following. For every pair of constraints, right, we're in two space, so we need two constraints. We would check, the first thing we do, we check if they're active, if they're linearly independent, I mean. Okay, so we check if they're linearly independent. And then two, if so, check that the associated basic solution satisfies the other constraint. Right? There's three constraints, so if you have two that are active, then you just need to see if the other constraint is also satisfied. That would imply that it's a basic feasible solution. Okay. I'm going to stop here, and before we move on to the rest of the lecture, we're going to stop and then repeat A and B for constraints. First do it for, we did it for 1 and 3, so you do it for 1 and 2. And then do it for 2 and 3. And you'll see that you're going to need those answers for the Google form, form that's the lesson quiz for this particular lesson. Okay, you need that. Okay, so do that first, and then you can listen to the rest of the sequel to this video for the rest of the lecture.